people in this country say, well, we're using thermoelectric generating stations. Well, I'm sure I can build a house that consumes less electricity than an average R20 house does, using a heat pump as well.
So why do you suppose that our 2000 house you showed us was losing so much heat?
Because it's not very well built.
Is it just a poorly built R2000, or the whole R2000 concept
Well,
is wrong?
No, it's part of the problem in North America, period. We grew up with abundant sources of energy and there was never any concern for saving it. As a matter of fact, the corporations that controlled energy certainly weren't interested in saving it, they just wanted to sell it. And we just developed some terrible habits. And then we get into the forced air heating. Well, forced air heating, another thing, we don't have climatic zones. I don't have any problem with a forced air heating system in Oklahoma. And it probably has to have an air conditioning unit as well. And it seems like whenever you get to a situation where 60% of your energy demand is for cooling, then, maybe you should use forced air. But in this climate, and North America has never, in this climate, we have never, ever been able to get the right equipment for this climate region. It's all market density. So the best equipment we can get is for Chicago. But there's no equipment built for this climate. If we went over to the Scandinavian countries, then we could get the right equipment, but you can't get it in North America. And that's just economics more than anything else. And the fact that we haven't really tried to do a great deal of research. Like we retrofitted a house in White City. It was built in the 50s, and 2x4 wall, of course, and that's called an R20. Whether it is or not is another question. But in any event, we thermal upgraded it with reflective barriers. Took the siding off the outside, put the reflective barrier on the outside. You got to strap it because you got to have a space for reflection. And we laid foil in the attic right on top of the insulation. And it was a baseboard heated house. So we replaced the boiler. We put in a condensing boiler. It reduced the energy input in that house 72%. But we don't know what part of that was boiler, what part of it was the reflective barrier. And the problem with me is I don't have enough credibility to get the grants to do the research to test it, to find out which is which.
So you did the reflective barrier on the outside of the house?
Yeah, yeah.
Awesome.
It works better on the inside, but when you're dealing with an old house,
You
those
have to redo the whole inside.
those two pictures that I showed you there of the two houses that were built in the 30s, they were done on the inside. They gutted the whole house, they cleaned it right out and redid it.
Now, up to that one, I know that Sask Energy again visited that house, and it's not the only one, but that's one of Vic's houses where Sask Energy came and changed the homeowner's gas meter, thinking there must be something wrong.
Yeah, yeah, that's right, yeah.
Was there something wrong though?
Nope.
I did my house, they came and changed my gas meter too, but it was broken.
Oh.
But it corresponded with the
Oh, okay.
change. I think when you change your energy flow, if the gas meter's questionable, I think that will, it will cause it to fail.
Well, I mean, it's such a dramatic decrease. I mean, they've been on a monthly average payment of $300 a month. And of course, it reduced it down to well below $100 a month.
So let's talk about that house. I'm really interested in that, because my next game here is trying to figure out how to do retros. So did you change windows too, or did you leave the windows?
Not in that house, we didn't, no.
You still had a 70% decrease?
Yeah,
in-
72%.
So it would have been a double glazed window.
Oh, yeah.
At best, probably leaking like crazy, but you don't care about leakage.
The thing is, although it had baseboard heating in it, it's still radiation. I mean, it's a combination of radiation and convection because the heat rises up the wall and around like that. But infiltration isn't anywhere near the problem when you're using
And that's a slanted radiator behind you, and these are radiant heaters here, these electric baseboard heaters are the same as what you're talking about.
Yeah. Yeah,
It
that's
doesn't
right.
have to be under the floor, it could be like a baseboard.
Yeah, yeah,
And
yeah,
that's what they had, and they still got the same result.
yeah, yeah. Yeah.
Wow.
I
Is that easy to do?
I did one, and I can actually sort of separate the two factors a little bit, because I changed a shop from overhead radiant to radiant floor,
Oh, yeah.
and then a year later, no, in the next summer, I guess, the owner asked what he should do about the walls, because it was a syntacrete wall, and I said, well, just strap it with 2x2s and put foil back, and then put your siding on, or bubble foil, and then put your siding on. So he didn't add any fiberglass or styrofoam or anything. And anyway, I went back to him finally and said, did you ever find your bills to tell me what happened? And he did. He found that the bill before, the year previous, before it was radiant floor, the bill was $3,600 for the year. After he changed to radiant floor with a better boiler, it went to $2,400, and when he did the outside, it went to $1,600. So he went from 36 to 16, so what maybe not as good or dramatic as that one at Vic's, but I think also at that time, over those 2 years or 3, that there was some gas price increases at that time too, so I couldn't say for sure, except very, very dramatic and effective, and each mattered, the better boiler and the reflective foil.
So there would have been siding on the house to start with?
No, so there's another thing, there was siding put on.
What about yours, there was siding on it before? The old one must have had siding.
Oh, yes, sure.
Did you strip the old siding
He
off?
stripped the siding off, strapped the wall, put the foil on, and then strapped it again to fasten the siding. So the strapping was up and down. First strapping went on horizontally, and that gave 2 reflective barriers. The 2 reflecting both ways.
So there is a bit of space, a bit sort of an R factor space there a little bit, because there is strapping done.
But why would you take the old siding off
He did it.
No, but would you have to?
Well, I don't suppose you would. I don't suppose you would, but you have to put more siding on the outside.
Yeah, of course.
You know. And, you know, what they're doing is, of course, putting vinyl siding on, which I absolutely hate.
Yeah, if it was vinyl, you'd have to take it off. But if it was some of that, some older houses with real wood siding, why wouldn't you just strap over it?
But you could do, sure, yeah. Yeah.
So you could strap over it, put the bubble insulate, the bubble reflection, and then another strapping and put your siding.
Yeah, yeah,
So horizontal first and vertical for your siding.
yeah, 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 sure, yeah, you could do that, there's no reason why
Might
not.
not be that much.
Yeah, yeah, yeah.
Then what would you do around your windows if you have that extra space?
All the way around.
Yeah, everybody tries to relate R factor to the
Yeah,
reflection, and reflection doesn't have anything to do with R factor, it's reflection is what you're after. The R factor side of it is meaningless.
I was gonna challenge you when you were talking about the ICF house. I've got a friend that's living in an ICF house, but they've got forced air heating, so they wouldn't be taking advantage of the,
Well, it's still a good thermal envelope, but it isn't anywhere near what you'd have if you had radiant floor heating in it. Yeah, it's not hard to get the BTU per square foot ratio down to 5. I mean, it gets more expensive as it goes down, but
What's a passive house standard? 10 watts per square meter. What is that BTU per square foot? I don't know, I can't translate.
well, a square meter is 10 times a square foot, so it's 10 square feet. And
What is a watt?
So that's 100 watts.
about 3.
14? No, no, 3 square meters. 25,
Well, 15 kilowatts is 53,000 BTUs, and that's 17,000 BTUs per 5 kilowatts. 5 kilowatts is 5,000 watts. I could do all this simple math, but when it gets down to telling me what the ratio of BTU per...
okay. Just curious, we could figure it out.
we
Yeah.
got that, yeah.
So in an ICF house, then the key will be to actually put the bubble wrap on the ceiling,
Oh.
vapor barrier.
You should have a reflective barrier on every ceiling, doesn't matter what kind of house it is, but
Right,
most
but I
importantly...
mean, we're saying that ICF is sort of the optimum,
Oh,
but the
absolutely.
weak point will be
Yeah.
the ceiling.
Yeah, that's right. We did a fairly large house down at the Jord, which is just southeast of Regina, and It had a condensing boiler in it, and it was all an open ceiling, and there was absolutely no insulation up there at all. And the boiler was running full bore to try to keep it warm in there. So he put the foil up on the ceiling, and he had to reduce the operating temperature of the boiler down to 1/3 of what it was, just with foil. There was no R factor added
And
whatsoever.
that foil is just loose laid on top of the truck?
When you're retrofitting, yeah. I mean, if you're building a new house, of course, you want to strap it two ways and then add the drywall on the bottom of it. There's lots of shops now that are being built and they're just leaving the foil exposed.
Yeah, yeah, I've seen that.
How come you want that air gap?
I'm sorry,
How come you want an air gap on both sides?
to offer reflection. Foil is a conductor, and if something touches it, it just transfers heat right straight across. So you gotta have that space for reflection.
On both sides.
Well, it depends on design. I mean, there's lots of areas where you can have the foil. As a matter of fact, foil is made in numerous configurations. Some of it has vinyl, bubble, foil. Some of it is foil, bubble, foil. And then there's bubble, foil, bubble. That's usually for below concrete. But they all have their applications. And TVM is one of the most advanced companies technologically in the foil business. But you can buy foil from every price range imaginable, and there's better quality and poorer quality. When you're doing walls and ceilings, there's no reason to use high quality, you might as well. It's the reflection you're after, that's all you need.
So if you were doing a slab on